Today, we're about to attempt what Bugatti think is impossible. This is the $6 million Bugatti Persport that was crashed by Alex.
When the hypercar world thought things were calm, something shocking happened. Christian von Koenigsegg reached out to car content creator Mat Armstrong, causing big surprise in the car community. This move also seemed to challenge ideas from Mate Rimac. People are now talking online about power, pride, and who controls car innovation. Is this just smart marketing or something bigger and more serious? Join us in this video as we reveal the details. Koenigsegg CEO destroys Bugatti CEO. A notable shift has taken place in the automotive content space following an unexpected gesture from Swedish hypercar manufacturer Koenigsegg toward automotive YouTuber Mat Armstrong. Known for rebuilding severely damaged supercars and documenting the process in detail, Armstrong recently received an official merchandise package directly from Koenigsegg's factory in Ängelholm, Sweden. The delivery has sparked discussion across the automotive community because Armstrong has never owned, rebuilt, or previously worked on a Koenigsegg vehicle. The package reportedly contained official hoodies, t-shirts, and premium-branded merchandise typically associated with owners of Koenigsegg's ultra-exclusive hypercars. Koenigsegg produces only a limited number of vehicles each year, often between 20 and 35 units, making it one of the most exclusive performance car manufacturers in the world. Because of this rarity, branded merchandise is often viewed as an extension of ownership culture rather than general promotional material. What makes the situation more remarkable is Armstrong's long history with other elite automotive brands. Over the years, he has invested heavily in restoring high-end vehicles from Lamborghini and Ferrari. His projects frequently involve purchasing salvage or accident-damaged vehicles and committing significant financial resources to return them to factory condition using original manufacturer parts. Among the most high-profile projects associated with Armstrong is the Lamborghini Revuelto, a hybrid flagship model valued at approximately £425,000. Because hybrid hypercars need advanced electrical systems, precise drivetrains, and expensive replacement parts, taking on such a project required a significant financial risk. Another cutting-edge hybrid supercar that Armstrong worked on was the Ferrari 296 GTB, which posed serious mechanical and electrical restoration issues. Armstrong has rebuilt former Lamborghini vehicles, including the Murcielago and Aventador, in addition to these recent hybrid platforms. These restorations always involves finding rare original parts, fixing structural problems, and carefully recording each step of the reconstruction procedure. He offers thorough explanations on the vehicle's electronic communication networks, carbon fiber building techniques, and drivetrain systems in addition to direct cosmetic repairs. Armstrong had invested in Lamborghini and Ferrari cars for years, but the carmakers had not publicly acknowledged him or offered to work with him. The importance of Koenigsegg's outreach has increased as a result of this contrast. Despite having no past financial relationship with Armstrong, Koenigsegg initiated contact rather than reacting to direct commercial involvement. It seems like a calculated gesture. Koenigsegg is well known for both engineering cleverness and performance. The company has created cutting-edge technologies, including the hybrid drivetrain system in the Koenigsegg Regera and the light-speed transmission in the Koenigsegg Jesko. Koenigsegg's engineering-focused mentality and Armstrong's content approach are quite compatible. Armstrong focuses on describing how systems work and how damaged components are repaired, whereas many automobile influencers prioritize high-speed reactions and lifestyle pictures. Koenigsegg's image as an engineering-driven business, rather than just a luxury brand, is seen in this analytical approach. Christian von Koenigsegg, the company's creator, is famous for being clear about technology growth and actively interacting with car lovers. His approach to leadership places a strong emphasis on accessibility and creativity in a market niche that would otherwise be exclusive. According to observers, the company's approach to Armstrong may have been motivated by this mindset, which acknowledged their mutual love of technical precision and open teaching. Several potential next moves are recommended by industry analysts. In one scenario, Armstrong goes to Koenigsegg's production facility in Sweden to record the process of handcrafted assembly. A visit like this would provide a unique behind-the-scenes look at the production of hypercars in small quantities. Another option is for Armstrong to drive or evaluate Koenigsegg products for the first time, offering a genuine response from somebody who is unfamiliar with the brand but is extremely knowledgeable with high-performance cars. A recorded repair or restoration partnership would be a more innovative development. To preserve their exclusivity and brand image, hypercar manufacturers have historically distanced themselves from the salvage rebuild culture. Allowing a reputable independent builder to demonstrate the repair procedure, however, would indicate a change in the hypercar market toward more openness. Armstrong's reputation was established by his diligent work, long workshop hours, and thorough documentation of intricate rebuilds. His efforts were driven by his skill and perseverance rather than official collaborations or sponsorships. Koenigsegg's choice to reach out implies an awareness of influence outside of conventional advertising avenues. However, this gesture just destroyed Bugatti because of the ongoing challenge between its CEO and Mat Armstrong. So, what moment sparked a deeper conflict? What is the turning point that changed everything between Mat Armstrong and Bugatti CEO? Stay tuned for more, taking on the impossible. An independent repair team has started what many people believed could not be done outside of a factory setting. The car at the center of this bold attempt is a $6 million Bugatti Chiron Pur Sport. It is not just any hypercar. It is one of the most advanced and exclusive machines in the world. And now it sits inside a normal workshop, damaged, taken apart, and waiting to be saved. The car was originally crashed by its owner. After the accident, the insurance company paid him out. Most people would have walked away at that point. Most people would have let the car disappear into the system. But he chose a different path. He bought the damaged car back. And then he made a call to Mat Armstrong, asking a simple but serious question: can this be repaired? When the car first arrived, there was already a lot of work ahead. Damaged body panels had to be removed. The windscreen had to come out. The airbags that had deployed during the crash had to be taken out carefully. The entire interior was stripped. Seats, trims, carpets, all removed piece by piece. But as more parts came off, more damage was found. The most worrying discovery was around the gearbox area. On both sides, what looked like a serious crack could be seen. That is not small damage. That is the kind of damage that can decide the future of the entire project. If the gearbox casing is badly cracked, the cost and difficulty of repair could be extreme. So before any repair could move forward, the team needed to fully inspect it. To do that, something major had to happen. The rear of the car needed to be separated from the front. On this car, the engine and gearbox sit in the rear section, while the front holds the carbon fiber monocoque tub. Splitting those two halves apart is not a small job. Public statements from Mate Rimac have made it clear that this kind of work is not meant to be done in a regular garage. It has been said that only a few places in the world have the right tools, the right equipment, and the right training to do this safely. The reason is simple. The car is filled with complex systems. Electrical wiring runs from front to back. Oil pipes, coolant lines, fuel lines, and hydraulic systems all connect both halves together. It is not just a matter of undoing a few bolts. On top of that, Bugatti is not providing parts or support for this rebuild. That means no factory instructions, no official step-by-step guide, no special tools sent from the manufacturer. The team is on its own. Even so, they moved forward. The first step was to begin removing the rear quarter panels. At first, it looked simple, but quickly it became clear that the side skirts were not separate parts. They were built into the rear quarter assembly. That meant more bolts had to be found and removed. Trim pieces were carefully unclipped. Door seals were taken out to reveal hidden fasteners. Carbon fiber sections were loosened slowly to avoid damage. Once the quarter panel came off, it revealed something interesting. Instead of being glued or bonded permanently to the structure, many of these large carbon fiber sections were bolted on. That was surprising. It meant the car, while extremely advanced, was also designed in a modular way. Next came the engine cover. There was no simple latch like on a normal car. A grille had to be removed first. Once that was out, only two main bolts were holding the rear hatch in place. With those removed, the cover lifted off, exposing the powerful W16 engine underneath. The rear wing followed. It was secured with multi-spline bolts and smaller fasteners along the edge. Once those were undone, the wing lifted away cleanly. The rear bumper and diffuser assembly came off as one large unit. The design allowed it to slide free once the right bolts were loosened. Slowly, piece by piece, the rear of the car began to open up. The impossible task was starting to look possible, but the hardest part was still ahead. After successfully beginning the disassembly of the Bugatti Chiron Pour Sport, the real challenge now begins. Can it actually be rebuilt again? Let's find out. Disconnecting the machine. With the body panels removed and the rear structure exposed, the real work began. It was no longer just about visible parts. Now it was about systems, fluids, wires, power, and structure. Underneath the car, the team identified 14 titanium bolts that hold the rear section to the front monocoque. Titanium is not used by accident. It is strong and lightweight, but also expensive. These bolts are what physically join the two halves of the car together. But before touching them, everything else connecting front and rear had to be disconnected. The battery was the first major system to address. It was not a normal battery. It had 4 terminals, 2 positive and 2 negative, all linked together. Once disconnected and removed, more space opened up to see deeper into the car. Next was the prop shaft. This connects the gearbox at the rear to the front differential. Before removing it, the team carefully marked its position to keep balance alignment correct for reassembly. It was then disconnected and set aside. Coolant lines ran along the sides of the car, linking front radiators to the engine at the back. These had to be disconnected carefully. Fluids were captured and saved. Without factory guidance, it was important not to waste anything that might be special or hard to replace. Hydraulic lines were next. There were multiple lines running front to back. Some were believed to control the nose lift suspension system. When opened, green hydraulic fluid came out. It appeared to be central hydraulic fluid, but without official confirmation, every drop was collected carefully. Brake lines also had to be disconnected. Each rear wheel had its own connections. On top of that, more hydraulic lines per wheel were identified. The complexity was clear. This was not a simple sports car. This was a machine built with layers of engineering. Inside the cabin, the accelerator pedal had to be removed to access wiring beneath the carpet. Large electrical looms ran through the carbon fiber tub. Connectors were unplugged and threaded carefully through openings in the structure. Interestingly, all the wires appeared white, which would make troubleshooting extremely difficult in the case of fire or damage. On the sides of the tub, more wiring was housed inside protective boxes. These were opened, and more connectors were unplugged. Eventually, the front wiring loom was separated from the rear loom. Coolant reservoirs were also removed. There were separate systems, one for the engine and another for the turbochargers. With these out of the way, hidden structural bolts became visible. At this point, nearly everything connecting the two halves had been undone. Electrical connections were separated. Hydraulic systems were disconnected. Brake lines were free. Coolant lines were open. The prop shaft was removed. The battery was out. Now only the 14 titanium bolts remained. The team raised the car and began loosening them one by one. No factory tools, no official training, just careful work and mechanical understanding. The first bolt came out successfully. It was a small moment, but also a huge one, because with that bolt removed, the impossible no longer sounded so impossible. The project had moved from theory to action, and the separation of a $6 million hypercar inside a regular garage was no longer just an idea. It was becoming reality. After the growing debate between independent rebuild efforts and Bugatti, the real question is, can this hypercar truly be rebuilt outside the factory? Let's delve deeper. The big debate about the broken hypercar. The story began when a very expensive and very rare hypercar became the center of a huge public debate. The car involved is a $6 million Bugatti Chiron Pour Sport. This is not a normal car. This is a super powerful, extremely advanced machine built for speed, performance, and engineering precision. Because of how expensive and rare this car is, every small repair decision becomes very important. The car crashed and was badly damaged. After the accident, the owner received money from the insurance company. Many people would have just sold the damaged car to a scrap buyer, but the owner decided to buy the car back. Then the owner contacted automotive content creator Mat Armstrong to try something very bold. He wanted to know if the car could be rebuilt using independent repair methods instead of sending it back to the factory. This decision immediately created controversy. The chief executive of Bugatti, Mate Rimac, publicly spoke about the situation. He made it very clear that Bugatti does not want to support independent repairs for this type of car. His main argument was based on safety, engineering complexity, and brand responsibility. One of the first things Rimac talked about was price rumors. Many people online had been saying that Bugatti headlights cost around $150,000 each. That number spread very quickly on social media, but Rimac explained that this was not correct. He said each headlight actually costs about $25,000. That means a full pair costs about $50,000. Even though $50,000 is still extremely expensive, it is not as shocking as the internet rumors suggested. Rimac explained why these parts cost so much. Hypercar manufacturers spend millions of dollars on research and development. These cars are not built in large numbers. Bugatti only produces a small number of vehicles each year. When production is limited, development costs must be shared across fewer cars. That makes each part very expensive. But price was not the main issue. Safety was the main concern. Rimac explained that the damaged Chiron had hidden structural damage. Some damage could not be seen from the outside. The car's carbon fiber monocoque structure may have internal cracks. The gearbox housing was also damaged and showed signs of cracking. This is serious damage because the gearbox is connected to high-power engine output. This car can reach speeds above 250 miles per hour. At those speeds, even small engineering mistakes can become dangerous. Rimac said repairing this type of damage requires factory-level tools, equipment, and training. Normal garages usually do not have this level of technology. The Chiron is built like a very complex system. Electrical wires, fuel lines, coolant pipes, hydraulic systems, and electronic computers all connect the front and back sections of the car. To repair the car properly, technicians often need specialized factory machines to separate the chassis safely. Another important topic was airbags. Rimac explained that hypercar airbags are not universal parts. They are carefully calibrated for crash performance. Even Bugatti engineers sometimes need special testing equipment to make sure airbags deploy correctly during crashes. Installing parts that only physically fit but are not properly engineered could create safety risks. Bugatti also said they offered to repair the car at their factory, but the owner chose independent repair instead. According to Rimac, Bugatti must prioritize safety and protect customers who buy new vehicles directly from the company. Despite this explanation, many people started disagreeing with Bugatti's position. They believed the safety argument was not the full story. This is where social media responses became very important. One person strongly challenging Bugatti's position was FX Alex G. His arguments were simple but powerful. He asked why Bugatti would refuse to sell headlights if safety was really the main issue. Headlights do not affect structural safety. They do not require splitting the car in half. They can be installed by trained mechanics without factory equipment. His argument made many people start questioning Bugatti's policy. If safety is the real reason, then Bugatti could still sell non-safety parts like lights, trim pieces, or cosmetic panels. But Bugatti's policy appeared to refuse selling almost all parts for independent repair. This debate quickly became bigger than just one car. It started becoming a discussion about car ownership rights. Many people started asking whether expensive car owners truly own their cars or if manufacturers still maintain control through parts availability. The controversy also started affecting brand relationships. Some people believed manufacturers might start using safety arguments to control repairs in the future. Others believed manufacturers have the right to protect their engineering designs and customer safety. As the debate grew louder, the rebuild project continued anyway. After the growing debate between independent rebuilders and Bugatti, the real question now becomes, can this rebuild survive without factory support? Or will the engineering challenges finally stop the project? Let's learn more. The Independent Rebuild Challenge. As the debate continued, the actual rebuild work moved forward. The project was no longer just about arguments on the internet. It became about real mechanical work inside the workshop. Mat Armstrong was not trying to restore the car to original factory condition anymore. That was almost impossible without Bugatti cooperation. Instead, the goal became proving that independent builders could still repair hypercars using creativity, engineering knowledge, and alternative parts sources. The rebuild presented many technical challenges. The front section of the car needed major structural work. The famous Bugatti horseshoe grille design is not just decoration. It is part of the structural framework. Because of this, fabricators must rebuild it carefully to maintain strength while keeping design accuracy. The team needed skilled metal fabricators, not normal body shop workers. Working on a hypercar structure is very different from working on normal cars. Materials are stronger, lighter, and more complex. Carbon fiber panels were another big problem. Bugatti would not sell replacement panels. That meant the team had to either repair damaged panels using advanced composite repair techniques or search for aftermarket solutions. Working with hypercar-grade carbon fiber is very difficult. It requires controlled temperature environments and specialized tools. Headlights were also a major problem. Even at $50,000 for a pair, they were still extremely expensive for an independent project budget. The team had to consider custom lighting solutions or alternative suppliers. Because of these challenges, community support became extremely important. The rebuild team started reaching out to former factory technicians, independent engineers, and private collectors. Some of these people may have access to rare parts or technical knowledge that is not available publicly. The project also represented a bigger social issue. Many people started worrying about the future of exotic car ownership. If manufacturers refuse to sell parts, independent repair becomes extremely difficult. This could mean customers depend entirely on manufacturers for repairs. Supporters of independent repair argued that skilled mechanics can repair high-performance cars safely if they have access to parts and technical information. Every successful repair proves that independent engineering is possible. Opponents argued that hypercars are extremely complicated machines. These cars are not built like normal vehicles. They are advanced, integrated systems. Even small mistakes could create dangerous driving conditions. The rebuild continues at independent workshops rather than at Bugatti's factory in France. Every step is being recorded publicly. The team is documenting challenges, solutions, and technical discoveries. The outcome of this project will be very important. If successful, it could change how luxury car companies handle repairs. If it fails, it may strengthen manufacturer control over parts distribution. As the debate between Mat Armstrong and Mate Rimac continues, the real question is, what is Christian von Koenigsegg planning? Let's take a closer look. The birth of dark matter technology. The story of this technology begins with a very simple but powerful idea. The engineers at Koenigsegg wanted to build something that most people in the car world believed was very difficult or even impossible. Electric cars were already becoming popular, but many electric motors still had limitations. They were often big, heavy, and could not always produce huge amounts of power from a small space. The man behind many of these ideas is Christian von Koenigsegg. He has always been known as someone who does not like following normal car industry rules. Instead, he prefers to ask simple questions like why things are built in a certain way and whether they can be made better. This thinking started when he was very young. As a child, he liked to take toys apart just to understand how they worked inside. That curiosity later turned into a lifelong passion for building fast and advanced cars. Koenigsegg was founded in 1994 with very little money compared to big car companies. There were no huge investors at first. There was no large factory network, but there was strong determination to build something special. Over time, the company became famous for building cars that could challenge much larger and older manufacturers. Some of their vehicles have broken speed records and shocked automotive experts. Before dark matte ER, Koenigsegg already introduced many unusual ideas. They built cars using strong but lightweight carbon fiber materials. These materials helped make cars safer while keeping them fast. They also worked on removing traditional engine parts like camshafts using a technology called free valve. This system allows computer control of engine valves instead of mechanical control. They also experimented with direct drive systems that remove traditional gearboxes to reduce energy loss. The dark matte ER motor was created because Koenigsegg wanted more power from electrification. The company noticed that most electric motors were still following old design patterns. They were either good at speed or good at torque, but not both at the same time. So Koenigsegg engineers asked a very important question. What if they could combine two different motor designs into one system? This idea led to the creation of axial flux technology. This design mixes two types of motor engineering ideas. Radial flux motors are common in many electric vehicles. They are good for high-speed operation, but sometimes struggle to produce very high torque in small spaces. Axial flux motors are more compact and can produce stronger torque, but they can be harder to cool and manufacture. Instead of choosing one design, Koenigsegg combined both. The axial flux design allows magnetic forces to move in two directions at the same time. This improves power efficiency and reduces wasted energy. Engineers used advanced computer simulations to study magnetic fields inside the motor. They wanted to make sure energy would move smoothly without creating hotspots where heat could build up. The dark matte ER motor itself is surprisingly small. It weighs about 39 kilograms, which is similar to carrying a large suitcase. But despite its small size, it can produce about 800 horsepower and 1,250 newton-meters of torque. This is extremely powerful for such a small device. Most electric motors of similar size cannot come close to these numbers. For comparison, the Tesla Model S Plaid uses 3 electric motors to produce high performance. Those motors together weigh around 90 kilograms. Dark matte ER produces similar performance using only one motor and much less weight. This means vehicles using this technology can potentially be faster while using less energy. The motor can spin at speeds up to 8,500 revolutions per minute. This allows very fast acceleration with almost no delay. When the driver presses the accelerator pedal, power arrives instantly. There is no waiting for gears to shift. There is no engine noise buildup, just smooth and powerful movement. Material selection was very important. The motor uses rare earth neodymium magnets. These magnets are extremely strong. Efficiency is another major achievement. The motor can reach about 95% efficiency. This means only 5% of energy becomes wasted heat. After Koenigsegg pushed electric performance limits, the real question is, how do they control all that power safely? Let's find out. 6-phase power and intelligent control systems. After building a powerful motor, Koenigsegg needed a way to control it safely and efficiently. Raw power alone is not enough. Without proper control systems, high-performance motors could become dangerous or unreliable. So engineers created advanced electrical and cooling systems to support dark matte ER technology. Most electric vehicles in the world use 3-phase power systems. This is because 3-phase power is reliable, proven, and easy to manufacture. However, Koenigsegg wanted something better. They decided to double the number of electrical phases and create a 6-phase system. 6-phase power works by using 2 groups of 3-phase electrical windings. These windings are slightly offset by 30 degrees. This design allows smoother rotation inside the motor. When electric motors run, they sometimes create small vibration patterns called torque ripple. Torque ripple can be felt as small shaking during acceleration. 6-phase power reduces this problem significantly. Another benefit is heat reduction. Because power is distributed across more electrical pathways, each wire carries less electrical current. This means less heat is generated inside the motor. Lower heat improves reliability and allows the motor to maintain high power output for longer periods. 6-phase systems also provide better safety. If one phase fails, the motor can still operate using the other 5 phases. In this case, performance might drop to about 83% instead of losing a full third of power like traditional three-phase systems. Power control is managed by an advanced electronic brain called the David inverter. This system uses silicon carbide semiconductor technology. Silicon carbide is better than traditional silicon electronics because it can switch power faster and operate at higher temperatures. The David inverter makes more than 100,000 electrical decisions every second. It monitors many things at once. It checks how far the driver presses the accelerator. It watches wheel grip on the road. It measures motor temperature. Then, it adjusts power delivery instantly. This system also helps with traction control. If one wheel starts slipping, the system can send more power to the wheels with better grip. This improves handling and safety during fast driving. Cooling was another very important challenge. High-power electric motors generate large amounts of heat. Koenigsegg designed a liquid cooling system that runs cooling fluid through channels built directly inside the motor structure. These channels are placed very close to the copper wiring where heat is produced. The cooling fluid is specially designed to absorb heat faster than normal water-based coolants. The heat is then moved to external radiators, where it can be released into the air. This allows drivers to use full power repeatedly without the motor automatically reducing performance to protect itself. All of this technology was eventually used inside the Koenigsegg Gemera. This car is very special because it combines hypercar speed with family car comfort. What do you think about the challenge posed by Mat Armstrong? Share your thoughts in the comments section below. Thank you for joining us as we explored the power of modern engineering and the mystery behind advanced electric technology. Don't forget to like and subscribe. Click the next video on your screen to continue discovering more stories. See you there.